Hey.
Hello. Welcome back, everybody. I hope you enjoyed the first talk of the day, but now we're moving on to number 2, Can You GitOps Your API by Abdallah Abedraba. We're going to be talking about contemporary cloud-native application trends in the development of GitOps. Take it away, buddy.
Awesome. You pronounced that actually pretty correctly.
Did I?
Thank you.
Oh, good.
Hi everyone. I'm Abdallah Abedraba. I work as a developer advocate at Kusk. And before I begin my presentation, I just want to say thank you for DI DevOps to invite me to give this presentation. This is actually the first presentation that I give as a professional developer advocate. And I'm happy to give it in such an environment and actually in Mackinac Island in Michigan. Yeah. In Michigan, of all places. So yeah, today I'm going to talk about if we can GitOps the APIs. And I think the answer of that is actually pretty obvious. We're software engineers, and we must be able to achieve whatever we want. But what I want to get out of this presentation at the end of the day is how we can actually build better or greater APIs than what we already have. And we all talk about the Stripe API, the Twilio API as being such a great APIs, but what does make an API great? Is it the documentation, the experience, or the right abstractions? And hopefully, with the proper tooling to build these APIs, you can achieve that experience. And so, setting the stage a little bit, what I'm going to talk in this presentation is a little bit about OpenAPI. So we're going to be talking about REST APIs and not GraphQL ones, but the concepts really apply for both of them. And then how to deploy these APIs using Kubernetes, for example, how to control the entry point of these APIs with what's called Ingress Controller or API Gateway. And then what is GitOps? I'm sure that we know about it, but I'll just make a little introduction and then how we can combine all these tools to build great APIs. And so, because we don't have enough time, or maybe I should say my ineptitude of making a shorter talk, I'm going to be a little fast in these introductions, and I hope to give you the knowledge of the tooling that is out there to be able to do that. So OpenAPI is a definition to define what an API is going to look like. So you can see there we have a hello path that has a get operation, and we even defined what the response is going to look like. And it's used to be called Swagger, and Swagger was its old name. It was bought by a company called SmartBear and then donated to the Linux Foundation. And renamed later to OpenAPI. So there's a little confusion out there of some people still calling it Swagger and some people calling it OpenAPI. Just know that the OpenAPI is the rebranded version and the one that's going to be maintained from now on. And so OpenAPI allows to have a technology-neutral approach. So OpenAPI doesn't need to know about the programming language that you're going to be using, and it doesn't need to know where you're going to deploy it. It just gives you a source of truth of what the API is going to be like. And that's really a contract that you can have between the consumers of the API and the producers. So for example, the consumers could be the front-end teams, and the producers could be the back-end ones. And because it is a contract, and just like with every contract, we don't use the contract at the end of the interaction, we use it at the beginning. And so if you are able to use OpenAPI early on in your API development process, you're able to enable these API stakeholders to collaborate further. So we can agree early on before committing the mistakes while building the APIs, or we can even have compliance teams ensure that everything is as it should be like. And I want to talk a little bit about the tooling around it that enables that kind of workflow to start working with OpenAPI. And for example, for designing the API, you have a tool like Stoplight, which allows you to design. It's an open source tool. Everything that I'm going to talk about here is open source. It allows you to design these OpenAPI definitions. It work in a team environment, even have policies, so all your APIs are designed in a consistent way throughout your entire organization. For example, one of the things that you can do is mock your API or provide fake results. So with Prism, for example, you can spin up a mocking server, and then your front-end team can use fake results while the back-end team is still writing the implementation of the API. And that way, they can really not depend on each other and work in parallel. You can even use code generation, for example, which takes the OpenAPI definition and makes some boilerplate code for you, so you don't have to write that all the time, and so it's a little faster. It works actually with every programming language under the sun. And finally, my favorite one is actually creating automatic tests that you can run against your API to ensure that at least it looks like what you're, it behaves the same way that you've defined it in the OpenAPI definition. Because we've all had this experience of using an API, and then from the documentation, we see how it goes, and when we try to implement it, it's really not the same thing. And then we get mad, and we talk to the API team, and we're having all these conversations, while Portman can just create, for example, these tests for you, and make sure that these conversations not happen, that everything is working as expected. And finally, the most famous use of OpenAPI is just generating these documentation or developer portals as well, where you can not only discover the paths and operations that you can do, but also play with the API and do stuff before even starting to use it. And this really boils down to what we like to call the OpenAPI driving the API lifecycle. So ideally, you would want to start from the left with design, mocking, testing, virtualization, documentation, and so on. And you would want OpenAPI to really fuel all these processes. Although at the moment, one of the hardships of OpenAPI is that there isn't such a good way of deploying OpenAPI APIs. Unlike, for example, GraphQL, which you have Apollo, which is doing a lot of that job for the community. And when it comes to deploying these APIs, the standard way of starting any project usually is with a monolith application, where you define all your paths and you deploy that monolith application into your server. And so people start using it. But at some point, when you're trying to scale this API, you find out that either the build times of your monolith application become prohibitive to have an agile type of workflow, but also, for example, if you have so many developers and you want them to work without depending on each other, it becomes a little cumbersome to follow that approach. And so usually what people have done is break it down into microservices. And these microservices really, for example, if we have a /users and a shopping cart endpoint in our API, each one of these microservices is going to manage one of these paths. And the cool thing about that approach is now your teams are working independently with their own programming languages and so on. And then when you're trying to deploy that API, these microservices, you'd usually package them up in a container. That's usually done with Docker. And hopefully when you try to deploy them, you run these containers in Kubernetes. I'm not going to tell you if you should or not use Kubernetes. I know that Whitney is going to be talking about that tomorrow, so be sure to tune on that. But the cool thing about Kubernetes is that it not only enabled us to break our application down into microservices and have all these agile workflows and so on. It also enables us to control the infrastructure where we're running the API and all the servers that we can have, that we can join them as a cluster, and then Kubernetes can scale up and down that cluster as needed. And really, when you're working with Kubernetes, it's a configuration-driven approach. And really what that means is that you have a configuration file that describes what the cluster or how the cluster should behave. And then you give it to Kubernetes, and Kubernetes, with its abstractions, will try to apply this configuration or reconciliate what you're expecting the cluster to look like with the actual state of the cluster. And so Kubernetes have built abstractions to deploy your applications. One of them, as you can see on the right, is the pod, which, for example, encapsulates your application, service, manages the networking around your application, ingress, and so on. And we're going to shift gears a little bit here, the European gears, the manual ones, not the automatic. to talk about API gateways, because really when you're talking about an API, at the end of the day, you cannot talk about it without the entry point of an API. So this is actually what an API gateway is. It's the door to all of your APIs. And usually what it would do is, if it receives a request that needs to go to the user's path that is managed by a specific microservice, an API would usually route that traffic. And that was the traditional use of API gateways. But then we realized that we could put more stuff in that layer, like, for example, some global rules of rate limiting, authentication, course, and even advanced rules like intrusion detection, aggregation of multiple microservices into one consumable API, and so on. Transformation, validation. There's really so many features that you could do on the API gateway layer. And the way that an API gateway is implemented in Kubernetes is with their abstraction, what's called an ingress object. So when you deploy your applications into Kubernetes, usually they're not deployed publicly, as in not being able to be consumed. And so you would need to configure an ingress, which would make that application that you have public, and then would route that traffic. And so the ingress is the object, and an ingress controller is the implementation of that object. And you can use many ingress controllers out there. For example, Nginx ingress, Ambassador traffic. These are some open source ones, but you can use Kong as well, and so on. Open source. Kong is also open source. And an API gateway in the Kubernetes realm is also considered to be an ingress controller. So you might hear them interchangeably, but they really mean the same thing. And the way to configure that ingress at the moment is through as we said before, the ingress object that Kubernetes can allow you. And so in the left side, you can see what that configuration looks like. But the ingress object was a little basic. And when we wanted to start using all these other features of an API gateway, as we talked about before, like rate limiting, authentication, and so on, we realized that we needed to flood our configuration with annotations, which is like an extended way of extending these configurations. Either that, or we usually went through the route of having custom definitions or configuration files, which you can see on the right side to configure that. And you might, if you've listened to Heidi's presentation, you might know that these specific abstractions are harder to maintain on the long term. So the challenges with the current ingress controllers is that because you have a specific configuration of how to configure these ingress controllers, you end up having a vendor lock-in. But what's even worse is that you have so many YAML files to manage, and this increases so much the complexity of deploying that. And then, due to the nature of Kubernetes, ingress controllers are generally configuration driven, as we said before. So we want that configuration of the ingress controller to be managed by the devs, but it's really usually done by the ops team. And the devs then would work on evolving the API. And if we're in a DevOps conference, we might know that just because we talk about DevOps and how anti-pattern it is to hire a DevOps engineer and so on, doesn't mean that the tools out there are simple to manage. The reason why so many people are falling into the different understanding of DevOps is because we don't have toolings that really abstract and simplify stuff to be able to achieve that DevOps culture. And so, shifting gears one more time, let's give a little introduction into GitOps. So basically, with the GitOps approach, you probably are familiar with it. You probably are doing it. Maybe you haven't named it GitOps yet, but I hope you can do so from now on. But usually, with the GitOps approach, you put all your configuration files into Git, and usually a provider of Git like GitHub. And then, with all the bells and whistles that gives you, you can then deploy these applications with CI/CD pipelines and so on. And the GitOps approach in Kubernetes is actually pretty powerful because it not only allows you to have review workflows, versioning, and so on, you can use tools like from big projects like Argo and Flux, which are continuous delivery tools that take these configuration files from GitHub and they apply them into your cluster. And one pro tip with these tools is that you don't only need to use Kubernetes configuration, you can have whatever configuration that you want as long as you can provide these tools with a way of translating it into Kubernetes configuration. And finally, this GitOps approach enables you to recreate infrastructure as needed. As in, if we have mayhem and oral clusters go down, it's a good thing that we have our configuration in a Git repository, because then we can just spin up a new cluster, take all this configuration from Git and apply it to it. And so we can have this consistent state of our infrastructure. And so how can all these things come together? OpenAPI will provide the source of truth or the contract of your API. Kubernetes then provides the infrastructure for it to run it. API Gateway is the entry point to the world, and GitOps is the way that you can automate the entire thing. But you can really automate only the deployment of the API. At the moment, I don't think it's possible or plausible for people to automate the deployment of the ingress controller. And that's really the fly in the ointment, or the problem with ingress controllers, is that an API gateway, because it's an essential part of the API, it needs to evolve at the same time as the API is evolving. And you cannot just have different teams working and configuring each other. So the developer team is evolving the API, and then they need to wait in the operations team to deploy it. And so there is a workflow contention, and problems arise, and people start to fight. And then what if you could actually use this OpenAPI definition to configure the API gateway as well? So not only the functional aspects that we talked about before, like the paths and the operations and the response and request, but we can even configure the operational aspects, like the authentication and so on. And that would really make it possible to have a single source of truth of the API. You wouldn't need any new configuration. You're just using a standard language, yay, or specification, which is in this case OpenAPI. And then finally, you can actually do that to automate the entire deployment of the API. And that's actually what we've done, and now we're happy. And that's actually what we've done with Kusk Gateway. It's an open source project, MIT licensed, and all the beautiful stuff about open source. And Kusk Gateway is basically a Kubernetes API gateway built on Envoy, which is another open source project that is super cool and well-tested piece of software that is being used by so many other gateways out there. And then Kusk, what really makes is allows you to have your OpenAPI configuration also configure the gateway for you. And so what this looks in practice is somewhere similar. This is your OpenAPI definition. You're writing it. It's the standard way of configuring it. And then you have a small section out there, which is called the x-kusk section, where you add your gateway features. You deploy that, and you can then run and check your APIs. And what Kusk is doing here is just taking this OpenAPI definition and converting these configurations to Envoy-specific configurations, which are pretty cumbersome and hard to maintain. And so this is actually possible because of the power of OpenAPI extension. OpenAPI allows you to have a way to use non-standard configurations, which are called extensions, by just adding the x dash in the beginning. And so what that would allow you to do is for example, with Kusk, configure all the gateway configurations like upstream routing, the cores. And one of the cool things is because the gateway is aware of the OpenAPI definition, it can then mock the results for you. It can then validate the request for you. And so you can have less complexity on your microservices going behind you. And this is what we really want to call the design-first approach that we talked about earlier. If we start working with the OpenAPI definition early on in the process, collaborating with different stakeholders and using all these open source tools from the OpenAPI ecosystem to manage it, plus combining them with the GitOps approach, we have the API ops, where we can have the entire lifecycle of the API really just automated and allowing for a DevOps approach. You can generate mocks, you can server stubs, so like the boilerplate code that we talked about, you can generate the tests, execute them, generate documentations, and this all comes for free just when you're using OpenAPI in this approach. And all that is really thanks to OpenAPI and the open source tooling that is out there and the ecosystem that's behind it. And so mission accomplished. Now we have OpenAPI, again, providing the source of truth of the API. That's a tongue twister. Kubernetes providing the infrastructure to run your API gateways, expose your API to the world, and adopting these workflows of GitOps and API ops finally can allow you to have a safer road to production and hopefully enable these DevOps workflow in your team. So if you want to check the project, go ahead and check it in GitHub, open issues, pull request, all that kind of jazz. And if you want to talk more about APIs or OpenAPI, please connect with me on Twitter. So thank you. Yeah, that's it. If you have any question, I'm happy to answer them.
We do have questions.
Woo!
Thank you so much for that talk. It was fantastic. We've got a couple of questions for you. Question number one, what if we don't have an application to serve? We have artists that work on 3D rendering tasks, and the only thing the tech team does is manage their virtual workstations and render nodes. Where are the APIs? I'm not sure what the paradigm is at a place that uses technology but does not produce software, so there is no source code being delivered outside of the company and nothing being served to external clients. Can this GitOps plus OpenAPI paradigm be applied to non-server infrastructure?
So if I understand the question correctly, they're saying that they don't have a public API to expose to a customer, but they have it internally, perhaps.
Yeah, that's what it sounds like to me.
Yeah, I would still think that this OpenAPI is really necessary if you're developing an API overall. That or GraphQL. At the end of the day, you want to have a way to think before you code, and OpenAPI provides that abstraction to you. And then with all these toolings, of course, you can have a happy path to production. So I guess it's still useful in both cases and scenarios, regardless of the use case.
Thank you very much. Question number two. While Gateway API isn't 100% baked yet, is there a plan to potentially port Cust Gateway into the Gateway API project? I think as an extension is the Gateway lingo.
That's a nice question. And actually, the other day I was listening to the podcast for the maintainer of the Gateway API. And the reason why he actually started is the same reasons that we wanted to start Cust Gateway, is that annotations become extremely hard to maintain in Kubernetes. And they wanted a way to create a new API for Kubernetes to approach that, and so that's why the Gateway API is there, but it's still in beta version. Mm-hmm. Hopefully, once they get out of the beta version, we can start using them, but not at the moment. But it's still on our radar, for sure.
Gotcha. Thank you. I see several people typing in Q&A, so I'm going to ask a question of my own while they get their questions out. I noticed that you repeatedly used the phrase continuous deployment. I'm a big fan of continuous deployment over continuous delivery because I am not a scared baby. So you personally, how do you feel about the argument between the CD standing for continuous delivery and continuous deployment? It sounds like you're very pro-continuous deployment.
Actually, I haven't thought about this before. I guess I'm using continuous deployment because that's how I understood it from the first time. But really, I honestly like both terms. They for me, define. I'm not a word fetishist in that case. I wouldn't care about using both terms as long as the vocabulary is understood by my team and we're all on the same page. I'm happy by using either of them, honestly.
Fair enough. So you're happy automating the deployment part and
yes,
having no human involved in pressing a big green button to have something out in the wild.
That's exactly what I want.
Good. Okay, that's continuous deployment, and that is the correct and true and powerful way to do it.
The right version of it. Continuous deployment it is from now on. I'll think of you next time when I'm talking about continuous deployment.
Thank you. I have a talk about it myself. It's basically just 20 minutes of me screaming at a captive audience.
Oh. So if you want to know more about continuous deployment, please watch Customer's presentation.
I mean, I think it's like, do you want to die on that hill or not is usually the question for a lot of folks. And I think similar to our speaker, it's like, why not either or? Like every organization kind of does it differently. And it's like, yes, I'm not a giant baby and I'm not afraid to deploy whenever, excluding Fridays. Just watch it happen.
The day before a holiday at 4:45 p.m.
But it's like you have to know your audience, kind of like alluding to Heidi's talk earlier, where it's like you have to know what you're building for and you kind of have to know what state your organization is as well. Like, where is that culture shift in terms of DevOps and where they're moving in terms of innovation as well?
Exactly. Thanks for that, Anna.
For sure. Well, thank you very much for speaking on it. I think the folks that were about to ask questions actually ran away. So I guess like for me, the question that I had for you as we were talking about this, like, when do you decide that you finished improving your GitOps technique or that you've actually implemented like a full-on robust like GitOps plus open API? Like at what point are you like, this is like a good state? Or is this something that you also feel like is continuous and you're continuously improving on it?
Everything is continuous in life, I would say. But especially honestly with GitOps approach, I would say you're kind of done with it or you're in a sufficient state when your team feels that they're safe pushing code and deploying as much as they can. If your team is not able to do that, and you don't need to deploy 10 times a day, you can do that 1 time a week if you want, but at least you need to enable that. And the GitOps approach, if tuned correctly, people are not afraid of merging into main without and knowing that they're not going to break anything and that everything is out there to save them. Not only they can still make mistakes, but the GitOps approach also allows you to roll back and all this kind of stuff. So as long as it's a safe and psychologically good environment while you're coding, then I would be happy with that.
That's also kind of how I see it. Psychological safety. Where are your engineers kind of like looking at that culture?
Yeah.
We actually have a new question that just popped up. You may have actually touched on this, but are there test generation tools to make sure that the implementation of my API doesn't drift from the open API spec? Basically, I want someone to yell at me if I change the contract without updating said contract. So really much on that continuity. Thank you for one of our IRL speakers on here asking good questions too.
Yes, this is one of the things that I probably glossed over quite quickly, but definitely there are tools that can create contract testing. And so whenever you write this open API definition, hopefully you're doing that before implementing the API. You can just have these tests generated for you and then run against the API and then ensure that at least what you're claiming to do with the API is actually what your API is doing, which is pretty important. But not only you can do contract testing, you can have load testing that can generate K6 tests and so on. Probably you're familiar with that. Chaos engineering, but also many other types of API testing. So, and yeah, the cool part of using OpenAPI is that it allows you to really not have to worry about that. They're just generated for you, and you just focus on the API directly.
That's actually super awesome. I had no idea about that. Using the contracts for those tests, using the contracts for the tests. Yes,
contracts.
Yeah, but on the open API spec specifically of it. So always good to know you're doing things reliably and that you're actually already thinking ahead of I'm building things that are going to fail. So let's go.
Really, the worst experience is when you as a user are using an API it differs from the way it's in documentation, but it's even worse for a company because of the experience that generates. And it's really a must to have these kind of testing running ongoing. We usually have the unit test, the integration test, but we don't have these contract testing that can save us from having these bad experiences.
Definitely. I'm a huge fan of doing all the tests, load testing, K6, contract testing now too, so feel for it. Well, thank you once again for sharing all this knowledge with us.
Thank you. Appreciate it.